when we put an addition sign inside with the cosine function, we actually do have something from the past that we can relate this to that I want to start off with. So like if you as a youngster had graphed y equals x squared and then wondered what happens when y equals, say, x minus 3 squared, you might remember that if this function looked like this, then this would be the same function, just moved 3 over. It shifts it to the right or to the left. This is going to have a similar effect. Well, that's kind of a problem for us. I don't know if you see that, but like if I take this beautiful cosine function, and if our whole graph is based off of where it crosses the x-axis and where those like high and low points happen, if those all shift over, finding those new values is kind of not fun, right? But we're going to use the same trick we used when there was a multiplier. We know that this graph begins and ends in terms of like new values, repeats itself from 0 to 2 pi. Right? So I don't want to say it begins and ends at 0 to 2 pi because it has all real numbers as a domain. But what's happening at 0 goes through, and what happens at 2 pi we start to repeat at that point. So we're going to do a similar thing. We're going to figure out what value of x makes me take the cosine of 0, so they equal to 0. What value of x makes me take the cosine of 2 pi, so I'll set this green expression equal to 2 pi. And because everything's shifting, it's not quite as easy as the multiplier. We're going to want to actually figure out what happened in negative 2 pi as well. So I'm going to add another equation to this. And in beautiful dark blue, we'll see what's happening at negative 2 pi. So the expression inside there, let's do all this stuff in black, is that x minus pi over 4. I want to know what value of x is going to make that equal negative 2 pi. I'm going to want to know what makes that expression on the inside equal 0. And I'm going to want to know what makes it equal 2 pi. So that I can pinpoint where all of these places move to. Now it's helpful always to have common denominators. So every place, since I'm dealing with a pi over 4 based off the problem, I'm going to replace these 2 pi over 4s and negative 2 pi, this negative 2 pi and this 2 pi with an equivalent value that has a denominator of 4. Can I be more awkward? Negative 2 pi, I'll think of that as negative 8 pi over 4. And positive 2 pi, I'll think about that as positive 8 pi over 4. So that's still 2 pi, the denominator is 4. That's still negative 2 pi, but the denominator is 4. Let's solve these things. Let's do the middle one first. That's the easiest. If x minus pi over 4 equals 0 and I want to solve for x, I'll add pi over 4 to both sides. So that'll be x equals pi over 4. And then this guy, 2 pi, I can think of that as 8 pi over 4. If I want to get this x by itself, I'll add pi over 4 to both sides. So x would equal 8 pi over 4 plus 1 pi over 4. So that's going to give me 9 pi over 4. Let's deal with this first. Bum, 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 bum. All right. So what was 0 is now pi over 4. And then what was 2 pi is now 9 pi over 4. And if you watch the other video, right, you know that I'm going to focus on moving my face up here. And I'm going to ignore the fact that it's a pi on both and a 4 on both. I'll think about what's happening between 1 and 9. And I'll find the average of 1 and 9. And I'll find the average of these endpoints. And I'll find the average of these endpoints. So I know that I'm going to have, this will be 5 pi over 4. This will be 3 pi over 4. This will be 7 pi over 4. This is where 0 used to be. Now it's here. 0 is now pi over 4. Cosine at 0 goes up 1. So at pi over 4, I'm going to go up 1. I'm going to go down to the 0 line. I'm going to go down 1, back up to the 0 line, and back up. Now I got to go this way. So now I got to deal with what happened in negative 2 pi. So let's write this neatly. This expression was x minus pi over 4 equals negative 2 pi. I'm going to think of negative 2 pi as negative 8 pi over 4. Right? That's still negative 2 pi. It just has a denominator of 4. If I add pi over 4 to both sides, I'll get that x by itself. So x is equal to negative 7 pi over 4. for some reason, this tablet I use makes my 4s look like 9s. So negative 8 pi plus 1 pi is negative 7 pi over 4. So now I'm thinking about getting from here, let's see, dark blue, here's negative 7 pi over 4. And I got to break this interval into pieces. So I'm thinking about going from negative, this is kind of messy. Let me clean things up. Switching to green ink here, but we want to go from negative 7 pi over 4 to pi over 4. We want to break that in half. And if you watch the other video, you know I'm starting at negative 7. I'm going up to 1. The average of these two numbers is negative 3. Average of these is negative 1. Average of these is negative 5. So my other points are going to be negative 3 pi over 4. Negative 1 pi over 4. This is negative 5 pi over 4. So pi over 4 is where 0 was. Goes up 1. It goes back down to here. Down to negative 1. Back up to the 0 line. Back up here. And I'm going to have this beautiful graph when I'm done. It's a lot to think about. Most of what we're talking about is arithmetic that you learned when you were a youngster. We're just slapping some pi's in there. We're slapping some non-denominators in there. And at the end of it, once you know where these x values have moved to, you got to think, am I going up 1? Am I going to the 0 line? We'll work it out. So now we'll put all this together in one hideous graph. And we'll see how this goes. I don't know, guys. I'm kind of excited. I hope it goes well. If you're feeling a little confused, go back and watch some of the simpler videos like that where we just talk about the numbers and see how that goes. And stick with it, man, because you can do hard things. I know you can. I do.